Welcome everybody to SureCloud's monthly cyber threat briefing. Today we're going to be talking a little bit about cloud security. We're going to focus on three key topics. So the benefits and risks of migrating to the cloud, shared responsibility model, why it matters, what's important, and then really a bit more about implementing secure by design and looking at compliant cloud infrastructure. So as usual, I'm joined today by Aaron. Hi, Aaron.
Hi.
Aaron's hopefully going to be giving us some insights into how some of the cloud security models that he's seen kind of apply, really. So I guess we'll start at the beginning. So I'm really interested in some of the benefits, Aaron. Obviously, we see a lot of things, around what the perceived benefits of cloud security and using cloud architecture are. But what are the real benefits, in your opinion?
So, as you said, there's the kind of highly publicized benefits around being able to have very flexible and scalable resources, and that's great. It means you can fit the kind of product to your business, but there's a lot of kind of security benefits that come with it, as well as operational benefits to cut down costs on deployment and move things forward. Things like native segregation is fantastic. Something that companies have always struggled with is implementing segregation within their internal networks, so that only the correct systems that need to talk to other systems can do that. By default, cloud providers will almost enforce it upon you. So with AWS, you have virtual private clouds where they encourage you to put one project in one kind of bucket. And that in itself is almost like your previous internal network. And beyond that, it requires external routing. So that's a great benefit to start with, in that if one of the boxes does get compromised, it makes it much more difficult to move on to other web apps, other high value bits of infrastructure. The next benefit, which is really around kind of operational development and DevOps, is the easier integration to CI and DevOps pipelines. You can hook in your production infrastructure and your development infrastructure with the same products that you're using to manage your code and do development. So things like Git, so that when you're pushing changes into your development and master branches, those changes are immediately deployed into your cloud infrastructure. Obviously, that has its own risks, where you need to make sure that changes are tested thoroughly before being pushed into production, because the changes happen almost instantly and could impact the availability of your services. But that kind of increased flexibility means that should you identify issues, or if you're pushing out new features, you can do that much more quickly.
So it's interesting you started really with flexibility and scalability. I guess that's what most people attribute to the cloud. But I guess also one of the key things is sort of total cost of ownership and expenditure. So what are your thoughts on kind of how that can benefit organizations?
So I guess if we jump back previously, if you wanted to set up a new service and it was going to require infrastructure to be set up, you'd have a significant capital expense in buying that infrastructure to just be able to start even working on that project. The cloud allows you to move those costs into operating costs that come through on a monthly basis, spread the cost out over a longer period of time, instead of having to have this huge upfront cost. That obviously can be tailored to fit your finance model. All the cloud providers give you the opportunity to buy credits up front and that kind of thing, if that fits your finance model better. But on the whole, most companies would rather hold that capital expense, reattribute the funds, use it to kind of further the business, and just pay a lower monthly operating cost on their services. So that's a nice move in terms of financing, so that you're not having to deal with that massive upfront cost just to get a new service live.
And I guess those things really go hand in hand, don't they? That kind of balanced cost that people can spread over a period of time, and scalability and flexibility as well, because you kind of made the point about it being easier to bring new systems and platforms online and build that into sort of business as usual processes. I guess the cost and spreading that out is enabling that flexibility as well, isn't it?
Yeah, absolutely. And with cloud, there's this large move to infrastructure as code, and kind of managing the deployment of your infrastructure and its maintenance using a purely code-based management system, things like Terraform. It does increase complexity, but it can save you both time from setup. If you think that you have to deploy 5 servers, ultimately it will take a bit more time to set up your kind of underlying management scripts. But once you need to repeat that, and if you need to repeat it hundreds of times over the lifetime of that application, it takes seconds when you're doing it using kind of infrastructure as code management.
Okay, so that's interesting. So obviously, on-premise environments were obviously physical equipment, and there was lots of kind of heavy lifting and shifting to get things racked and stacked, so to speak, before we could start building them. So what does the cloud give us in terms of sort of serverless, versus host-based? What's your view on that?
So both options are provide more flexibility, I guess, is the key thing. If you need a full host and you want to be able to manage multiple points in the application stack, the ability to go for host-based or virtualized machines is great. But if you need something that performs a specific function at a very low cost, serverless applications offer a great avenue. So you could host specific functions for your API, for example, which might only be called a few times a day. You can have those running in a serverless kind of configuration, and you'll essentially only pay when your function is called. So you can massively cut down costs. Instead of having to have a on-premise server that handles just handling the API or handles multiple APIs, you can just have essentially be paying for the exact amount of CPU time that you use. So I guess that's the financial side of it. With the serverless deployment, you also have the benefit of the whole stack up to your code is essentially managed by the cloud provider. So you don't have to worry about patching the kind of underlying infrastructure, the different levels of software. For example, if you're running a Python-based API, you don't need to worry about making sure that the Python is up to date. You simply need to make sure that your code is compliant with the latest version of the kind of code software that you're using.
Okay, so that's interesting. I think obviously, the benefits are largely visible there. I guess the difficulty comes with security, doesn't it? So you touched on a few points there, and obviously infrastructure as code can bring some of that benefit around sort of deployment and making things more simplistic. But I guess security becomes more repeatable at that point as well, doesn't it? So where I guess do the responsibilities cross over? How do they impact on security within the cloud?
So across all cloud providers, there's what's implemented the shared responsibility model. So the best way to think about it is understanding how far up the application stack, from kind of raw networking to hardware to hypervisors, all the way up to running your own code. Exactly what will the cloud provider do and what will they update, what will they ensure is secure, and what is your responsibility? Typically, there's no overlap in those. There will be a section of things that are responsible that you as a user are responsible for, and a section of things that the cloud provider is responsible for. You can kind of think of it as almost a scalar move from on-premise, where you're responsible for everything, and you can move right the way through infrastructure as code, which is your kind of virtualized host, all the way through to software as a service, where you simply have the only thing you manage is the data and potentially any customizations on top of that. Your ultimate responsibility is very low. The key issue that comes out of this is clients of cloud providers not fully understanding where that deviation in responsibility lies. Because if there's an oversight, you think that the cloud provider is covering something, but they will stand fast by the fact that if it's not in the agreement, they won't cover it. Those things can be missed and can be left unpatched or unsecured. You as a user may never even think to have secured it in the first place. So it leaves an opportunity for these holes to arise.
So I guess the key takeaway there is really important that you get the shared responsibility matrix right then. I know that a lot of the cloud providers obviously publish those, because they're public documents. But I guess what should organizations be doing to ensure that they've covered off the gaps and know what their own responsibilities are?
I think it's key to understand, preferably in the design phase, but if it's already been deployed, going back and reviewing the different services that are in use, and exactly what the cloud provider is defining as their responsibility and your responsibility for those services, and making sure that they're covered in both your policies and your technical controls.
And how does that affect what we deal with in a day-to-day security model? Obviously, there was a time when people could go and sort of touch it and feel it, and if we had problems, we could sort of go and pull plugs on it and turn it off. But how does that shared responsibility, it seems like people obviously have to rely on that contract a little bit more now to ensure that they're getting the service that they need in order to help protect themselves.
Yeah, this is absolutely true. There is a lot more of an emphasis on you relying on the cloud provider to make sure that they're holding up their end of the bargain. It's worth noting that all of the cloud providers have insanely high availability SLAs that can be relied on. They've been kind of tried and tested. Cloud providers do meet these SLAs for availability, especially if you comply with their kind of additional guidance on how you should deploy your applications. So, for example, AWS might encourage you to deploy your application across 2 different availability zones. So it'll be deployed in 2 different data centers, and that will increase your SLA kind of availability percentage so that there's even less chance of you having any downtime.
So what's I guess the $1 million question for most people is what does that partnership look like when you're working with the cloud provider? Obviously, the likes of sort of Amazon and Microsoft, massive enterprises. How well supported do you feel people are when they're using cloud environments?
It's always a challenging one. The larger you are as a user, the more support you'll get. Large enterprises that are in that kind of multiple £1 million a year budget will have people that they can call if there's the slightest issue, and they'll have technical support. It's a bit tougher when you're a smaller company. If you're on a sub 100K budget per year, the support is very limited. You'll kind of get raw technical support for availability, but in terms of configuration and kind of management of your devices, you're very much left up to your own devices.
Okay, so still a balance really for organizations to kind of understand that shared responsibility and where they can rely on that support and where ultimately they may need to think about internal processes still. That's really interesting. So I guess at this point it'd be good to release a poll because I think it'd be good to hear everybody else's view. So we've got a multi-choice poll this time, and we're interested in sort of your thoughts about sort of migrating to the cloud and what you've either experienced or haven't experienced. But I guess while you're thinking about that, it'd be good to maybe think about the third topic that we've got around sort of implementing secure by design. I guess this is the one that I'm most interested in, Aaron, because having worked with clients with on-premise and very much kind of people-to-people businesses, it's a very different model of working, isn't it? And a different way of creating a secure by design model. So what's the key hints and tips really? Where have you seen this work really well?
Okay, so I think the best way to go about implementing a secure design is to follow a couple main points. The first one being to make sure that you understand what you need, your requirements from the application or the service that you're setting up, but also from your wider cloud environment as a whole. Then going about actually implementing it in a way that fits your requirements. And then some further hardening steps, like things like enforcing the use of templates and validation activities. So we can kind of dive into those a little bit as to the things you need to think about in going about implementing that.
So I guess before we do that, though, there's a key difference, isn't there? Because this isn't a lift and shift from the environments that we've had running in physical data centers for years and years. This is a whole new model, isn't it? This is a start from the ground up, kind of implementation.
Yeah, absolutely. This is it's the perfect opportunity to migrate things. It's very rare that you're going to have to make a large scale change like this in the future. And I guess the cloud almost accommodates that not needing to be a feature in the future because of the nature of which you can flexibly deploy new hosts and they can be updated. You can migrate your apps, especially in the serverless applications. They'll almost update automatically the underlying software. So you simply have to keep tweaking your code to make sure it's staying current. it's moving away from this model of having a server and once it works, kind of not touching it again until it gets to a point where it's so out of date that it becomes almost a liability, either from availability or from a security point of view. The cloud almost pushes you into a more dynamic environment, which obviously has its own operational costs, but ultimately should improve security as a whole.
So I guess I'm interested in your first point around understanding the requirements in that case, because obviously the requirements for having a server and deploying a service as an organization is obviously very different when you're designing that, as you've just kind of articulated. So what are some of the key things to be aware of when understanding those requirements and defining that model?
So there's a few things to think about. And if you think about it at your whole cloud level, rather than at a specific service or application level to start with, it's understanding what kind of policies you want and controls you want to implement in your wider cloud infrastructure. There's an element of mapping those to the cloud provider's responsibilities as a whole, because you don't want to be trying to re-implement controls that are ultimately already handled by the cloud provider, because in doing so, you'll be adding unnecessary complexity without actually adding any benefit. There's an additional counterpoint to kind of understanding what your requirements are. Because of the fluidity that cloud offers, there's a reasonable chance that you define your requirements, you start building something, and then your requirements change. So this understanding your requirements piece isn't a one-off step. It's all continuously developing as your use of the cloud and as your kind of business model changes as you move forward. If you're offering different services, that kind of thing, you need to make sure that you're continuously reviewing what your requirements are from the cloud, what things are going to be covered by the cloud provider, what things you need to look to implement.
Yeah, it's interesting because a couple of the other points you kind of made were around building the environment, and that build is not one time, is it? You're not deploying sort of physical pieces of hardware and not forgetting about them for a period of time. This is a constantly evolving landscape, isn't it? Where you're changing what those requirements are, how you apply those, and this kind of continuous model of improvement as much as anything else to keep up with what you're doing as a business. So is this really where the templates come in to be able to help kind of sculpt what that is and to speed up that deployment and sort of management?
Yeah, exactly. So once you've defined what you want from your environment and what each kind of service or host that is required to do, you can use templates to restrict what users restrict what, for example, your development team are allowed to spin up and how they're allowed to spin things up. So if you want all hosts to have, by default, to have no ports open to the internet, to have the firewall enabled by default, you can implement that with a template. And basically what you're enforcing a kind of a baseline gold standard, much in the same way that traditionally you'd have a gold standard image for servers or you'd have a gold standard image for a workstation. You can do it on a wider scale for applying controls to different bits of cloud infrastructure. So you might not necessarily have a specific template that just covers creating virtual machines. It might cover a wider scope of kind of serverless architecture and still push the same controls, but you have this kind of gold standard baseline that you're going to use to make sure nothing deviates from that.
Okay, great. I guess at this point, just to remind people that the poll is still active. You are also able to ask questions through the chat panel. If you have any questions for Aaron, we'll move on to some questions in a minute. But Aaron, I guess that's all well and good, but how do we validate that? One of the key points here is around compliant cloud infrastructure. How do we validate that those things are happening and working as they should be?
So this is always going to be a balance, as it always has been traditionally, for whether or not you do point-in-time assessments or if you use ongoing validation. And as always, it's got to be a mix of the two. Having those point-in-time assessments are great to kind of understand the current snapshot state, look for kind of areas for improvement. But the ongoing validation piece, especially within the cloud where it's so technology driven, you can start to offload a lot of that kind of controls auditing into technical controls, and lots of cloud providers will offer you services that can be like leveraged to do that. Many will have a variety of controls implemented by default that will alert when the cloud provider's controls fail, but you can add additional controls to monitor the things that you've put in place, where they can test every minute of every day without faltering and alert you as soon as something deviates from what you're expecting. So if somehow a developer creates a box that doesn't comply to what you expect, you can get an alert. It can be investigated before it becomes a security issue. So there's a balance of this kind of regular point in time assessment, but the ongoing and the ongoing validation. But I guess the key thing that cloud offers that wasn't traditionally possible with on-premise infrastructure is the ongoing validation, continuously assessing the environment to make sure that it's matching the templates and controls that you put in place.
And I guess a question then, a personal question. So from the context of what you do every day, how effective is that validation from those sort of integrations? How does that give that security benefit to the organization?
So the default kind of off-the-shelf monitoring is quite effective, assuming that if the alerts are actually monitored, it's quite often that those alerts aren't even checked. But if they are being checked, it does put you in good stead to have a good kind of baseline. It won't check any of the controls that you have put in that fall into your kind of area of the shared responsibility model, which is almost a blind spot. So I certainly wouldn't rely on them entirely. Looking at either adding controls or your own kind of monitoring for your area of the responsibility model is key. But it does provide a single source of information that helps build up an overall picture.
Great, thanks. So I guess there's some other points that lots of people talk about. Obviously, data in transit and data at rest, and we've touched on that a little bit. But how does that apply to things like the IAM profiles and being able to potentially have the concept of a humanless cloud? What's your thoughts on that?
So IAM within the cloud offers so much more granularity than was possible before. Because of the way that cloud providers are configured, most of the time you can apply roles to the instance itself. It will use a metadata service to gain access to those credentials only as and when needed. It allows you to push down much more granular controls, allows the specific things that host needs to function. So in the event of compromise, there's very little you can do. The idea of a humanless cloud leans very much into the infrastructure as code piece, where your devs will manage the kind of ongoing life cycle of the application or service through Git or an equivalent code management service. And from that point, the code is pushed to a pre-configured host. The code is pushed to a pre-configured host that's already been checked that it's secure, it's going to be repeatable. There's no opportunity for mistakes to be made in almost en route in the reconfiguration. So if you can do that, there doesn't even need to be user accounts within the cloud to manage those services. It just means that in the event of a compromise of one specific host within it, or it completely removes the ability of an attacker to try and move laterally, because every permission set is granular to the point where, unless you're trying to do the exact function the application or service was designed to do, you won't be able to do anything with it.
Yeah, so I guess that complexity is also something that can bring sort of some confusion as well in sort of fault finding more than anything else. But obviously, there's a lot of impetus you've just put there on sort of having more control at a developer level. So how does kind of secure development come into this, and does that shift the problem, or does it just create a different problem somewhere else? What does secure development look like in the cloud?
So when you're using these infrastructure as code and the automated deployment, it's really important to push your security left in the development kind of life cycle. There needs to be input from like relating to security right at the early design stages to think about how is it going to be implemented from a host architecture level down to a code architecture level, to understand what the ultimate goals are while also considering security. Because of that, you can kind of because you have that early involvement, you can be doing code reviews and testing as soon as the application is ready. And because everything is managed through essentially a code management database, it allows much better tracking of changes. So if you have a test completed on the application and a year goes round, you can look at the changes that have been made and do much more targeted testing. Ultimately, it cuts down your testing time and should mean that your final product is more secure.
So this focus on automation really is about reducing that risk and reducing that threat landscape as well then. So I guess, whilst there is complexity in sort of operating within a cloud environment that is different to maybe the legacy systems that organizations are used to dealing with, it sounds like the security model that can be built out within the cloud gives a lot more granularity and a lot more flexibility for organizations to secure their environments more. Are there any other kind of casing points, I guess, that you want to close with, Aaron?
I guess just to kind of jump onto the point you made about the additional complexity as well as the kind of additional granularity, it's almost a double-edged sword. You have this much more finite control, and it's much easier to implement those kind of fine-grained policies and much easier to deploy things quickly. That almost goes hand in hand with the potential for substantial costs. There was a really interesting HashiCorp article the other day where they essentially interviewed a number of representatives from companies that had cloud budgets from 3 to 10 million. And about 40% of them said that they'd overspent their budget by 40%, which is obviously a substantial increase in total expenditure. And there was a variety of reasons for that, between kind of changing priorities, which is obviously something that the cloud is great for. If you do have a change in business need, you can quickly modify what you're doing to accommodate that. But also there was a significant number where the cost essentially was unintended spending, either hosts being spun up and not being kept track of, development projects that had been abandoned but left running and essentially are paying to keep them up. So lots of benefits in terms of control and potential cost savings and potential time savings. But if things aren't managed well, there's potential for those costs to spiral.
Yeah, great. Thanks, Aaron. So, I think we've sort of certainly learned quite a bit around sort of cloud security. I guess we've had a couple of questions. So one is more around migration and how organizations can prepare their data for migration to the cloud. Obviously, you made quite a big point about it being a new model and a different way of working, so to speak, at an operational level. Is there lots that organizations need to do to prepare data for migration?
So on the most part, cloud providers have databases that are compliant with standard database infrastructure. So in many cases, databases can be lifted and the actual content can be lifted and shifted. It's obviously, again, if you're making this large move, it's worth reviewing those databases, making sure that they contain the appropriate information. You aren't unnecessarily storing excessive information, that the data that you're storing is compliant with your policies, that kind of thing. It's a once in a very long time opportunity to make sure that you are doing what you think you're doing. But yeah, the actual migration of the data itself shouldn't pose a significant challenge. But I would certainly look to migrate the data into a cloud native database rather than try and clone the host itself and migrate it, because you'd essentially be bringing your legacy infrastructure with you to potentially sting you in the future when it hasn't been updated because it falls into your area of the responsibility model.
Yeah, so very much looking at that rationalization, kind of review and rationalization piece, and taking the opportunity to migrate it to something new rather than sort of bringing that old legacy potential problem into the cloud as well. Okay, that's interesting. So we had another question around sort of how we can help clients that have multiple public clouds, particularly against things like misconfiguration. You obviously talked a bit about templating and things like that. What are some of the key things to be aware of when people are using multiple cloud environments that potentially have different models for applying sort of security?
So I think most of it pivots around understanding your requirements and then mapping those to the specific cloud providers, kind of their responsibilities. So you know what they're responsible for, because in each case it will be different for each cloud provider. There's a interesting point about interfaces that might have been added during cloud adoption pilots, which is always a tough one to spot, especially as cloud environments grow. You get this additional complexity, and it's often difficult to attribute what specific things are to the kind of projects that they're linked to. All the cloud providers offer really good tagging functionality. And if you're looking to migrate to the cloud and you're in an early stage, I would very much encourage proactively using those tags so that every project has the resources related to it tagged. Everything is tagged for its purpose, its point of contact, all of these things. So ultimately, if somebody comes to look at a resource later on and it potentially doesn't meet the model because you're using that kind of cloud monitoring and you've got your own monitoring in place, you detect something isn't what you expect, you can use those tags to work out what that resource was created for. There's definitely a challenge around if there's a resource that's running and you don't know what it's doing, working out what it's doing, because you have that additional obscurity within the cloud where you can't go to the box and see exactly what it's plugged into.
I guess there's also a piece here around that continuous compliance monitoring as well, and leveraging the ability to keep watch over some of these things that get added or removed. So I guess the security model working hand in hand with that kind of compliance model is really important as well, isn't it?
Absolutely. And all of those compliance elements, because the way you can essentially query all of your resources within the cloud, you don't have this problem that often occurs in local networks where you have devices that are connected to the network, but nobody is quite sure physically where the device itself is, because you don't have a physical device to manage. It's always going to be listed within your kind of cloud dashboard, or you can break down into the different types of devices you have. It's always going to be enumeratable. You don't have this problem of a distant device that you have no access to.
Okay, thanks. So you've got a final question around sort of the difference between services like Webflow and WordPress in terms of the cloud web perspective and their risk profiles. So what's your thoughts around Webflow versus WordPress?
So this is an interesting one. Webflow is offered as a software as a service. So you simply manage the data that's held within it and the limited code that you can kind of add on top. Whereas WordPress has a variety of installation methods. Most users will host it on a virtual machine kind of infrastructure as a service. So there's a much larger stack. WordPress also leverages a lot of plugins. So one of the key, I guess, issues is that most of these plugins are open source. Because WordPress is so popular, they are heavily scrutinized for vulnerabilities. And should one be found in a plugin, it can be replicated across every other WordPress site that uses that plugin unless you've added additional controls. Webflow has the benefit of essentially you're just inputting data to make the web application. There's limited kind of plugins that you can use. It's much more, I guess, much more of the stack is ultimately managed by the cloud provider. So there's much less for you to make a mistake on. So I guess from that point of view, there's an additional benefit for Webflow users in that because so much of the stack is managed, you can focus on a much narrower set of responsibilities, focusing on just the website. Whereas if you are using WordPress as a larger stack that you have to handle.
Thanks, Aaron. So we've got a final question before we wrap up, but focused more on an organization's responsibility for the actual security of the digital assets. So, the combination of potentially the infrastructure and the information and how we present that within the cloud. What's your thoughts around that?
So that's covered by the shared responsibility model, and it will be different for every different cloud service that you use. So, for example, an EC2 instance, a virtual machine in AWS, you'll be responsible for everything from the operating system upwards. So any software you install, how you manage your data on the device. Whereas you could use an Azure web app, which is much like Webflow, where you ultimately only manage the code that's deployed within IIS. You don't need to manage the web software itself. So managing assets and data, it will be flexible depending on which services you're using, and it's key to understand exactly what's your responsibility in each of those cases.
Excellent. Thanks, Aaron. So I guess that brings us to the end of this session, really. I think there was some really good thoughts shared there. Thank you, Aaron. I also thank everybody for attending. Our next one is towards the back end of next month. So it'd be really good to see you all again. But otherwise, have a good evening. Thanks from us and goodbye.